Hey, Mr. Scott here again. So, this video is going to be on chapters 3 and 4, which was all about quadratic functions and equations. Again, if you haven't watched any of the other videos, I always start with this one little line where I say, if you are watching this video but you haven't given these questions a try, stop right now. Stop. Go back, give them a try, do them on your own. I want you to get practice on your own, and once you've given at least every question a try, then come back and you can watch this video, see what you did right, see what you did wrong, and see how you can improve. But I don't want you just watching this video. This isn't a way to learn. Math is not a spectator sport. You have to actually try it. So, again, don't watch this unless you've already done these questions. Anyway, so we're going to begin with question number 1 on chapter 3. I'm only doing certain questions. I've just circled the ones I'm going to do, so I'll be skipping quite a few along here. But we'll start with question 1a. It says, find the vertex of each quadratic. Remember a little while ago I taught you guys a really quick trick on how to find the vertex. The vertex can be found by going x equals negative b over 2a. Of course, in order to do this, you have to be in standard form, where it's in the form y equals ax squared plus bx plus c. So that's just where you get your b and your a from, of course. But in this question, it already is. It's just we don't have a b and we don't have a c. So if we're going to punch this one in, it's going to be x equals, well, notice b is the number that's attached just to the x, not the x squared. Well, there is none there, so it'll be 0. Divided by 2 times a. Well, 2 times a in this case, a is 3, so 2 times 3 is 6. So x is 0 divided by 6, which is of course 0. But we need a y coordinate as well. It's not just enough to have an x coordinate, so we need to find y by taking this x and plugging it back into our equation and getting y. So we'll say y equals 3 times 0 squared. Well, 3 times 0 squared is also 0, so our vertex for question 1a is 0, 0. Okay, as for question 1, part B, this is very similar once again, except we have it in y plus 3 equals negative 1/2 x squared form. Let's get y all by itself first. We don't like having y with anything on that side, so we'll minus 3 on both sides and get y equals negative 1/2 x squared minus 3. And so that gives us our a value of negative 1/2. Again, we don't have a b value, but we do have a c value of negative 3. So if we're going to find our vertex, it's going to be x equals negative b over 2a, or in other words, in this question, it's going to be 0 divided by 2 times negative 1/2, which is going to be negative 1, which is still just going to give us 0 as our vertex. But again, we do need a y coordinate, so we just need to plug in x is 0 into this equation. So we'll go y equals negative 1/2, the 0 we found in the x, and then minus 3. And that's going to give us a y coordinate of negative 3. So our vertex in this case is going to be the coordinate 0, negative 3. So question number 2, it's asking you to put it into vertex graphing form, also known as just vertex form is what I always call it, by completing the square. I'm only going to do part B here because completing the square is quite a process, but let's get started. So y equals x squared plus x minus 1. We'll write that down first. X squared plus x minus 1. To complete the square, it's kind of a process. First step is you want to put brackets around your x's. If there was a number in front of the x squared, we'd have to factor it out, even if it meant getting a decimal in front of this, but there is no number in front of the x squared, so we have nothing to worry about here. Second step, take the number that's in front of the x, which in this case is just a 1, and you take that number, divide it by 2, which is going to give us 0.5, and then square it. 0.5 squared is going to give us 0.25. Now what you do with that 0.25 is you have to add it on to this part, but then also subtract it. The whole point of this is we want to get a trinomial, so an x squared plus an x plus some number that we can factor using completing the square. So this number we have to add and subtract onto this. So we're going to change our equation. We're going to get y equals x squared plus x plus 0.25. and then minus 0.25, because what we add on we have to take off immediately, and then that minus 1 that was just hanging out on the outside right up there. So with this in mind, this piece right here can now be factored using, well, the sum product rule really, but the way to get around this is just to take advantage of this number we got up here. Whatever you divided the coefficient in front of the x by, well, you divided it by 2, I should say, but whatever you got when you divided it by 2, so 0.5, that is going to be the number that goes into your completed square. So we're going to rewrite this now. Because it was all positive up here and we had positive 0.5, we can change this as y equals x plus 0.5, that number we got there, squared, minus 0.25 minus 1. So this whole piece right here, that whole piece became this whole piece right here. And if you don't believe me, you can always expand this out by going x plus 0.5 times x plus 0.5, and it's going to give you this all over again. Anyway, the last thing we've got to take care of is this minus 0.25 and minus 1. That's pretty easy to combine though, so we're going to have x plus 0.5 squared minus 0.25 minus 1 is going to be minus 1.25. And that right there, that is now in vertex graphing form, and we're done. So question number 2, it's asking you to put it into vertex graphing form, also known as just vertex form is what I always call it, by completing the square. I'm only going to do part B here because completing the square is quite a process, but let's get started. So y equals x squared plus x minus 1. We'll write that down first. X squared plus x minus 1. To complete the square, it's kind of a process. First step is you want to put brackets around your x's. If there was a number in front of the x squared, we'd have to factor it out, even if it meant getting a decimal in front of this, but there is no number in front of the x squared, so we have nothing to worry about here. Second step, take the number that's in front of the x, which in this case is just a 1, and you take that number, divide it by 2, which is going to give us 0.5, and then square it. 0.5 squared is going to give us 0.25. Now what you do with that 0.25 is you have to add it on to this part, but then also subtract it. The whole point of this is we want to get a trinomial, so an x squared plus an x plus some number that we can factor using completing the square. So this number we have to add and subtract onto this. So we're going to change our equation. We're going to get y equals x squared plus x plus 0.25 and then minus 0.25, because what we add on we have to take off immediately, and then that minus 1 that was just hanging out on the outside right up there. So with this in mind, this piece right here can now be factored using, well, the sum product rule really, but the way to get around this is just to take advantage of this number we got up here. Whatever you divided the coefficient in front of the x by, well, you divided it by 2 I should say, but whatever you got when you divided it by 2, so 0.5, that is going to be the number that goes into your completed square. So we're going to rewrite this now. Because it was all positive up here and we had positive 0.5, we can change this as y equals x plus 0.5, that number we got there, squared, minus 0.25 minus 1. So this whole piece right here, that whole piece became this whole piece right here. And if you don't believe me, you can always expand this out by going x plus 0.5 times x plus 0.5, and it's going to give you this all over again. Anyway, the last thing we've got to take care of is this minus 0.25 and minus 1. That's pretty easy to combine though, so we're going to have x plus 0.5 squared minus 0.25 minus 1 is going to be minus 1.25. And that right there, that is now in vertex graphing form, and we're done. Okay, question 3 is also pretty bulky, but it looks worse than it actually is. There's several different parts to this. The first main part is, of course, to find the vertex. Ultimately, what we're trying to get through, as you see, we follow through all these steps. The ultimate goal is we want to be able to sketch the graph of that function. But we'll start by finding the vertex. So we're going to do question 2 here. I thought question 1 was a little bit too easy, so we'll go to question 2. To find the vertex, once again, we're going to go x equals negative b over 2a. In this case, b is 4 and a is 1, so we're going to go negative 4 over 2 times 1 is 2, which in other words is going to give us a vertex, an x-coordinate of our vertex, I should say, of negative 2. To find the y-coordinate of that, you just take that negative 2 and you plug it back into your equation. So we're going to have negative 2 squared plus 4 times negative 2 plus 3, which is going to give us 4 minus 8 plus 3, or in other words, negative 1 is going to be our y-coordinate of our vertex. So we do know we have a vertex of negative 2, negative 1. So I will just record that up at the top here. If I just erase the whole board as we go. So the vertex will v is -2, -1. And we're going to hold on to that information for a little bit here. It'll be very useful in a moment. If you move on to part B of this question, the equation of the axis of symmetry, keep in mind when you graph something, especially a quadratic I should say, when you graph a quadratic, let's say it looks something like this. The axis of symmetry is just the dotted line that makes that thing symmetrical. If I had a better dotted line, it would make a little more sense, but you get the idea. It's going to be the line that makes it symmetrical. This line occurs at whatever the x-coordinate is of that vertex. Well, the x-coordinate of the vertex is -2, so in other words, the answer to part B is going to be x is -2. That's the equation of that axis of symmetry. X is -2. Part C, concavity faces up or down. Most of you guys already know how to identify this, but if you don't, well, now's the time to learn. It's not too hard actually. The way to tell if it faces up or down is just to look at the leading coefficient. Look at the number in front of the x squared. Well, in front of the x squared, technically we would just have a +1. Because that number is positive, that's going to tell us it faces up. If the number was negative, it'd be facing down. But because it's +1 in front of the x squared, that means it's facing up. So the answer to C, we'll just put up. Now, as for D, it says maximum or minimum value. Again, if I just redraw a rough sketch of a graph, the vertex is always your maximum or minimum. Because we know it's facing up, we can tell it's going to be a minimum point because it's facing up. So the minimum point, we'll say for part D, well, it's just your vertex. So -2, -1. As for your domain and range, this is where things are a little tricky. With a quadratic, your domain, so we'll go domain, your domain is always going to be x is an element of all real numbers. X could be literally anything. It could be anything way over here, it could be anything way over here. No matter what x you plug in, you're still going to get a y value. Now the range, on the other hand, is going to be a little trickier. The range is only going to be values of r that are bigger than your minimum value. Or I mean values of y, sorry. Values of y that are going to be bigger than your minimum value. So y values are never going to go below this point. And this point just so happens to be y is -1. So in other words, y is always going to be greater than or equal to -1. That'll be your range. Now, part F, x and y intercepts. This one's going to be a little bit more work, so we'll just erase what we've got down so far here. Hold on. There we go. So x and y intercepts, remember, if you're looking for a y-intercept, you have to set x equal to 0 and then solve for y. Usually finding y-intercept is a little easier, so we'll start with that first. So to find our y-intercept, let's just take our equation and set x equal to 0 and then solve for y. So this is going to be y equals 0 squared plus 0 times 4, sorry, 4 times 0 I should say, plus 3, which is just going to be 0 plus 0 plus 3, which is just going to be 3. So our y-intercept is going to be y equals 3. As for our x-intercepts, this is where it's a little bit trickier. You have to set y equal to 0. Let's just clean this up here. You're going to have to set y equal to 0 and then solve for x. So we're going to have 0 equals x squared plus 4x plus 3. We should be able to identify at this point, though, in order to find where this is 0, we're going to have to factor this. And because this is a trinomial with 3 pieces, we're going to have to look for a sum of 4 and a product of 3. Think of two numbers that work like that. Well, the two numbers that will have a sum of 4 and a product of 3 would be 3 and 1. And because there's not a number in front of the x squared, it's just a 1, we can jump right to the answer. So again, it's going to be 3 and 1, so we'll say it's x plus 3 times x plus 1. Now in order to find our x-intercepts, we have to solve for where that's equal to 0. So either this part is going to be equal to 0, because 0 times this will be 0, or this part is going to be equal to 0, because then 0 times this is going to give us 0. So if this part is equal to 0, that means x must be -3. And if this part is equal to 0, that means x is -1. So those 2 points right there are the points of our x-intercept. Now, for the very last one here, we want to sketch the graph, it says. So we want to take all the information we found, especially this y-intercept, this x-intercept, and our vertex that I've left up at the top. We want to take all that information out, combine it into one, so we can graph it. Now, for you guys, hopefully you have graph paper. If you don't have graph paper, I guess you're just going to have to do this by hand on a piece of loose leaf. But you're probably wondering, okay, well, what about you, Mr. Scott? You just got like a whiteboard here. How are you gonna graph something like this on a whiteboard? Like, you need a little bit more detail. Well, I got a secret for you. Bam! Hit you with a base 10 grid. Anyway, so here it is right here. We got a base 10 grid going on. We're gonna say this is our y-axis and this is our x-axis. Remember, we have a vertex of, let me double check. Oh, yeah, it's -2, -1. So we have a vertex of -2, -1. Let's say that is -2 and that is -1. So our vertex is going to be about right there. I'm not doing it very accurate here because these little dots are so tiny. I don't want it to be, too small for you to read. But then we also need to look at our y-intercept and our x-intercepts. Well, if we flip back again, our y-intercept is going to be at y is 3, and our two x-intercepts are going to be at -3 and -1. So perhaps we just want to put a point. Where am I going with this? Here we are. X-intercepts of -3 and -1, so x at -1 here, and x at -3 right here. And then our y-intercept is going to be way up at y is +3 up there. So that's going to be our y-intercept. This is going to be one of our x-intercepts. This is going to be another one of our x-intercepts. It's just going to be a matter of connecting the dots here. You could have also used that 1-4-9 rule I taught you guys a little bit before, but given what we already did in the question, this will be more than accurate enough. So just connect your dots. Remember, make it a parabola, which just pretty much just means an upwards facing U. I didn't do a great job here. Then again, I'm doing this with one hand. I can't really do this and hold the camera at the same time. But hopefully you get the idea. Just combine all the stuff you got in previous steps. Okay, so question number 4, write a quadratic equation in vertex graphing form for each of the following. We'll just do for part A. It gives you the A value and it tells you what the vertex is. Remember, vertex graphing form is in the form y equals A times x minus p squared plus q, where p and q are the coordinates of your vertex. So if it gives us a vertex already of -1 and 2, then that means we just got to replace p with -1 and q with +2. And it also tells us what a is, so this is just really a matter of just filling in the details. So y is going to be a, which is 2, so 2 times x minus -1, minus -1, you might as well just go +1, squared, plus 2. And that's all there is to number 4. Now, question number 5 is a little bit trickier, but I'm really highlighting this one because it's super important, especially for when you get into grade 12, where this becomes a very standard type of question. We're looking at the new equation of a parabola y equals x squared after you take care of these following translations to them. If we want to move this 2 units to the left and make a vertical translation 1 unit up, all we gotta think about here is if we had our normal x squared, which rests right on the origin, kind of like that, and it says we're moving it 2 to the left and we're moving it 1 up. Basically, all I would suggest doing is just think about where the vertex is going. The vertex is originally at the point 0, 0, but it's soon going to be at the point -2, +1. So -2, +1. As long as you take advantage of vertex form, this becomes quite straightforward. If we're taking our vertex and we're moving it left 2 and up 1, we're getting this as our new vertex. Nothing is happening to how much we're stretching the function. In other words, our a value on the vertex form is just going to stay as 1. So we can write this as y equals, again, this is our vertex -2, so it'll be x plus 2. Because remember, it's x minus p, p being the x coordinate of our vertex. X minus -2 is x plus 2 squared plus 1. And that is the equation of the new graph if we moved it left 2, up 1. 7 is the next one I want to talk about. Question number 6 I'm skipping. You should be able to try that one on your own. Just imagine the height of 12 being your maximum point, and it's going to be a downward facing function. I'll let you fill in the rest. But the height h in meters of a flare, t seconds after it's shot, is given by this equation. We're looking for the height at its maximum height. Well, remember, anytime you see maximum or minimum, you should be thinking vertex, because the vertex on a quadratic is always either its maximum or minimum. And because this is a downward facing function, notice the -4.9, the vertex is going to be a maximum, because on a downward facing, the vertex will be a maximum. So all we have to do here is we have to find the vertex. Remember, we can use x equals -b over 2a as our formula to find the vertex. The b value is whatever's in front of the x. Well, x is t in this case, so we got 61.25. So we'll make that negative 61.25 over 2 times whatever the a value is. So we'll go 2 times negative 4.9, which is going to give us negative 9.8. So if we go negative 61.25 divided by negative 9.8, it'll give us the x value of the vertex. So we'll punch that in right now. Negative 61.25 divided by negative 9.8 is going to give us positive 6.25. So we have 6.25 as being our x. And if we want to find the y, we just have to plug 6.25 into this equation. So we'll go negative 4.9 times 6.25 squared plus 61.25 times 6.25. And of course, looking like I did that correctly, it looks like our y value in this case is going to be about 191.4. So what height is the flare at its maximum height? Well, y is our height, and remember height is in meters, so it's going to be 191.4 meters is going to be the maximum height. And then it says how many seconds after being shot does this occur? Well, it's going to be 6.25 seconds after being shot. So question number 8 is the last one I'm going to do on this page. The farmer has 100 meters of fencing material. The diagram is already set up for you. We want to figure out what the maximum area is. Well, remember, like I said in the last one, maximum is always your vertex. But notice we just have the dimensions here. We need to actually find an expression for the area. Well, the area in a rectangle is just going to be length times width. So it's just going to be x times 100 minus 2x. So x times 100 minus 2x. Multiply that through and you're going to get 100x minus 2x squared. And then you just want to use your vertex formula to find the equation of that. So it's going to be x equals negative b. Well, b is going to be 100 in this case. Remember, b is the number in front of the x. So it's going to be negative 100 over 2 times a. Well, a is negative 2, so 2 times negative 2 is negative 4. 100 divided by negative 4 is going to be 25. That's going to be the x value of what we got here. So all we need to do then is we need to figure out what our y coordinate is here. Well, actually, we don't even need to figure out what our y coordinate is. Oh, well, we do actually. Our y coordinate is our a. Sorry, I'm kind of losing my mind here. Y is our a value, and of course we need to find out what this a value is. That's our area. That's what the question is looking for. So area is going to be x is 25, so we're going to go 25 times 100 minus 2 times 25. So 25 times 100 minus 2 times 25. I'll just write that in as 50. So 25 times 100 minus 50, which is just going to be 50. Let's use a calculator just to be sure. 25 times 50 is going to give us 1,250. So the area of this, and it says it's in meters, so the area is going to be 1,250 square meters. Okay, so now we're going to switch over to chapter number 4. Remember, I'm combining these two chapters into one video. Question number 1, it says solve the quadratic equations by factoring. We got to see how we can factor question 1a. Well, first step is always to see what kind of greatest common factor you can bring out. Well, I can see right off the bat I can take a 3x out of both of those. So if we take a 3x out of both of those, we're going to have 3x squared divided by 3x is just going to leave us with an x, minus 36x divided by 3x is going to give us 12. That right there is all we can do to factor it. So if we're asked to solve this equation now, remember it was equal to 0 in the original question. It was equal to 0. All we have to do is actually solve for x values that make this true. So in this part up here, this is going to be 0. So x would have to equal 0 to make this whole thing equal to 0. Or in this part here, x would have to equal 12. So those are going to be our two solutions. X is 0 and x is 12. Okay, so as for question 1, part B, this one's going to be a little bit more complicated because notice in front of the x squared, we have an additional number. We have a 2 there. The 2 there is going to mean we can't just use our sum product rule like we've used on previous questions, and we can't just take a greatest common factor out because there's no greatest common factor between those 3 terms. So we're going to have to use our adapted sum product rule, which means negative 7 is still going to be our sum, but negative 15 is not our product. It's rather going to be 2 times negative 15 will be our product. So we're looking for two numbers that have a sum of negative 7 and a product of 2 times negative 15, which is negative 30. So think for a second, what two numbers would add to be negative 7 but multiply to be negative 30? Well, because negative 30 is a negative number, you know one number's got to be positive, one's got to be negative. That's the only way two numbers will make a negative product. So I would say it would be negative 10 and positive 3, because if you add those two together, you get negative 7, and if you multiply those together, you get negative 30. So instead of just jumping right to a solution with this, we have to use a bit of an adapted sum product rule. We've got to use these two numbers to break apart that minus 7x in the original question. So we can rewrite this now as 2x squared, and then instead of minus 7x, we'll change it to minus 10x plus 3x, and then minus the 15 that we have in the end in the first place. Now, to solve this, because we've broken that negative 7x up, we just have to put brackets around the first two, brackets around the second two, and then factor by grouping each one. So out of these two, we can take out a 2x, and that'll leave an x minus 5, plus out of these two, I could take out a 3, which will also give me an x minus 5. Since we have an x minus 5 here and an x minus 5 here, this has been a completed factoring by grouping, so we can write it as x minus 5 times 2x plus 3. And now for our final step, we have to see which, or rather how this is going to equal 0. So either this is 0 or this is 0. Well, if this is equal to 0, that's when x is 5. But if this is equal to 0, let's even do it the long way here. We get minus 3 on both sides to get 2x equals negative 3. Divide by 2, x is going to be negative 3 over 2. So our two answers will be x is 5 and x is negative 3 over 2. Okay, so question number 3 is the next one I want to do. Solve the quadratic equations using the quadratic formula and write answers in exact form. This means we don't actually have to calculate any of the square roots we have. We can just leave it as a square root, which is going to be really nice. So we'll just do this one, x squared plus 4x minus 96. I know it's not focusing very well, but it's question 4a, x squared plus 4x minus 96, plus 4x minus 96 equals 0. Before we use quadratic formula, you might say, okay, well, why are we using quadratic formula? Well, usually we use sum product. I can't think of any two numbers that would have a sum of 4 and a product of negative 96, at least not off the top of my head. So the quadratic formula can just solve any quadratic equation you throw at it. And remember, the quadratic formula is on your formula sheet. It's this really big long one up here. Pretty much it's just a matter of throwing the numbers that you were given right into that, and you'll find your x values. You're going to end up with two x values because of that plus or minus. Because remember, one of the equations will be negative b plus that whole mess, and then the other one will be negative b minus that whole mess. So you will end up with two answers, just like we saw earlier in the video with other questions that you just solved by the sum product rule. But anyway, let's throw the numbers in here. So a is 1, b is 4, c is negative 96. So it's just a matter of using this equation and throwing the numbers in. So first part is negative b, so it'll be negative 4 plus or minus the square root of b squared, so 4 squared, minus 4 times a, so 4 times 1, times c, which is negative 96, all divided by 2 times a. So in other words, 2 times 1, it'll be divided by 2. If we're going to clean this up a little bit here, because it does say just leave your answers in exact form, this will be negative 4 plus or minus the square root of, well, 4 squared is 16, so 16 minus 4 times 1 times negative 96, well, that'll be 4 times negative 96, oops, 4 times negative 96, which is negative 384, so we'll be adding 384 divided by 2, or in other words, negative 4 plus or minus the square root 16 plus 384, I believe that's going to be 400 divided by 2. Now it says leave your answers in exact form, so that's as far as you need to go. Square root of 400 is just 20 though, so this wouldn't be too hard of a question to express without exact form. But because it says exact form, feel free just to leave your answers with a square root. But again, we know square root of 400 is 20, so this wouldn't have been too bad of a question. Question number 6 now, it says find the discriminant and state the nature of the roots. It's been a while since we talked about the discriminant. The discriminant is actually just the part underneath the square root sign in the quadratic formula. And that whole thing there, that whole discriminant is going to tell you how many roots you have. So let's just find the discriminant of this first one here, x squared minus 4x minus 5. So we're just going to go b squared minus 4ac, sorry, b squared minus 4ac. So in this one it says negative 4 is b, so we'll go negative 4 squared minus 4 times a times c. Well, a is 1 and c is negative 5. So negative 4 squared is going to give us 16, minus 4 times 1 times negative 5 is going to be minus negative 20, so plus 20, which is going to give us 36. Now that right there, that's our discriminant. So that's our discriminant, and the whole reason this is significant is because this is a positive number. If you have a positive number as a discriminant, that means we have 2 roots. If you had a negative number as a discriminant, there would be 0 roots. And if you had 0 as a discriminant, that would mean there is 1 root. So just something useful to know. It can help us find the other roots. We'll do question B here as well, just to prove this. So that one says x squared equals negative 9. And you might actually be able to tell right at looking at that how many roots there's going to be, but just in case you can't, let's first put this into general form by adding 9 on both sides. So we'll have x squared plus 9 equals 0. Now we can use this because it's all equal to 0. We can use this and find our discriminant. So remember, our discriminant is going to be b squared minus 4ac. Well, b is 0. There is no b in here. There's no something x. So it would be 0 squared minus 4 times a, which is 1, times c, which is 9. So in this case, we'll have 0 minus 4 times 1 times 9, which is 36. Or in other words, we'll have negative 36. So negative 36 in this case is our discriminant. That's a negative number, so that means we have no roots. Okay, so for the very last one in this entire chapter 3, chapter 4 booklet is question number 8. That's the last one I want to talk about here. It says find t when h is 20. Totally gives the question away just by this part right here. 20 equals 5t squared minus 30t plus 45. We want to solve that equation, find t. Remember, if there's ever something on the one side, we want to make that side equal to 0. So we're going to subtract 20 on both sides there, which will give us 0 equals 5t squared minus 30t, and then plus 45 minus 20 is just going to give us plus 25. Now this would be pretty challenging, to try to use sum product rule, but notice we can actually factor out a 5 from all of these. This is going to give us 0 equals 5 times t squared minus 6t plus 5. So in other words, I just divided each of those terms by 5 and put the 5 on the outside. Now it's a little bit easier. We have a sum of negative 6 and a product of positive 5. And also notice there's no number in front of the t squared, so we don't have to do that really long sum product rule. We can just use the basic sum product rule. So sum of negative 6, product of 5, that'll be negative 5 and negative 1. So we can write this now as 0 equals 5 times t minus 5 and t minus 1. So this is going to be equal to 0 when either this is 0 or this is 0. So either t is 5 or t is 1. And those would be the solutions because there's no other information here. It's not like we're starting at a time of 2 or anything. So in other words, time is 1, time is 5. Both of those times are the answer. So with that, we're done chapters 3 and 4. Hopefully this helped. I know this one was a little longer, not quite as long as chapter number 1, I hope, but we'll see once I put things together, and that'll do it.